Hello, Uggies worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, and I'm here today with Ask Dave number 209. And we're going to do an exploration of the 2-meter band. And then when we're done with that, I want to talk a little bit about the current controversy surrounding it. But first, to the 2-meter band, why is it so important, and so on. This is often the first band that new technicians will try, and they'll try their local repeaters. Well, there's a lot more that can be done with the 2-meter band, and so I did a little drawing showing how the 2-meter band is divided into different modes and different types of things like that. So let's take a look at that. Before we do, I would like to ask you to please remember to like the video and to subscribe. And your subscription simply tells YouTube that you think this is a worthy channel. And then, if you want, you can also click on the bell that will pop up when you subscribe, and that will allow you to receive a notification through whatever notification mechanism you have that there is a new video. I try to do a new one every week, plus there's the Saturday live stream. So this week's is going to be about the 2-meter band. And don't forget, at the end, we're going to talk about the controversy surrounding the 2-meter band. Let's dig in. Before we explore the 2-meter band, let's take a quick look here at where the 2-meter band fits into the grand scheme of things. This is all the U.S. amateur HF and VHF and UHF bands here. These are HF, these are our new low frequency bands. 160 meters is technically a medium frequency band. 80, 40, 30, 20, 17, 15, 12, 10 are things that you get to use once you get your general license. 6 meters, all this stuff down here is available for technicians. Sometimes we think that these bands up here are just FM because we've always got handhelds that we get. Most new technicians' first radio is a handheld of some sort, which is fine, but don't stop there. The 2-meter band sits right here. It's kind of unique. By the way, in Europe, they have a 4-meter band that sits in between here. We don't have that. 6 meters is available on most HF radios now. Not all of them have it, but many of the new radios have 6 meters on them. It's a very interesting band and something that you can completely explore as a technician. The 2-meter is the one we're going to talk about. This is a very, very popular band. I would say that for the technician, this is kind of where everybody starts. It's nice to know a little bit about the band. Now, let's just kind of zoom in on 2 meters here, okay? 2 meters, this is the FCC regulation concerning it. Okay, it's got a little area that's got this squiggle in it, and if we look over here at the key, we see that that's CW only. So that's the first 100 kilohertz of the band is CW only. And then in the rest of the band, it's got both red and green. Red is Ridian data. Green is phone and image. And Morse code is allowed on all bands everywhere. Okay. Now that doesn't really tell us a whole lot about actually how the band is used. If you were to look at some of the other bands like the 40-meter band, you go, yeah, there's sideband up here, there's CW down here, there's data, whatever. Okay, so let's just take a look at what this is really. And that gets us into the subject of frequency coordination and band plans. The ARRL, you should know about them. I've made many times my pitch for joining the ARRL, and I'm going to do it again because of their spectrum defense. that they have. Okay, we're going to look at the band plan that the ARRL has for 2 meters, which is still quite general. And then we're going to work this down. We're going to take Colorado as an example of how Colorado takes this band plan and through an organization in Colorado called the Colorado Council of Amateur Radio Clubs, we work this down to what the actual frequencies in use are in Colorado. Every area has an organization like that. Every area has a frequency coordinator. The frequency coordinators are not necessarily directed by the ARRL. They are put together locally. It is a cooperative effort. Remember, all that the FCC says is what's on here, but there needs to be a lot more structure to the bands. Now, I looked at this and decided to do something a little different to see it. This is how the state of Colorado, the Colorado Council of Amateur Radio Clubs, CCARC, which is a radio club in and of itself, looks at the 2 meter band this way. Okay. Now, the problem with looking at the 2 meter band this way is it's still really quite general. I thought what I'd do is draw a picture of this, and I did that. And this is that picture right here. Okay, and it's got from 144 to 148 megahertz. That's 4 megahertz of spectrum. That's far bigger than any HF band. 4 megahertz of spectrum that you can do things with. And we're going to zoom in on it. Let's look first at the top part of the band, and let's zoom in on this, okay? A very small part of the band from 144 to 144.1 is CW, must be CW. According to the FCC, that part of the band is CW only, no digital modes, no nothing else. So that's 144 to 144.1. Now this is divided in half in the band plan. The top part, which is just 50 kilohertz, not very much, is used for Earth-Moon-Earth CW communications, okay? Earth-Moon-Earth, that's EME, CW. Now, as it turns out, CW is getting kind of obsolete for Earth-Moon-Earth. JT65 is what's actually used there most, so that'd be in a slightly different subband. Now, next down here, they have CW and weak signal in the next 50 kilohertz to fill out that 100 kilohertz of CW only. What they mean by weak signal is basically everything that where you're trying to work direct with somebody. And the thing about 2 meters that's really interesting is there's some very interesting modes of propagation that most people don't think about when they talk to their local repeater. But you can get troposcatter and things like that that will carry these signals hundreds of miles. And this is kind of the area where that's done. Now, 144.1 to 144.3 is both CW and single sideband weak signal. Okay, CW and single sideband. Now, you won't find that on a handheld. It's just not on a handheld. You have to get a different kind of radio. So we're talking about the first kind of radio that we'll see on 2 meters. And that is a, would have CW and single sideband and digital, etc. Okay, that's the first kind of radio that you can use on it. Now, so this goes up here, CW and single sideband weak signal is put right in there where you can really try your hand. People use sometimes enormous antennas. The antennas aren't very big on 2 meters, really, so you can make very high gain antennas and not have it be very big. Now, there's a little tiny slice of spectrum in here, 25 kilohertz, for propagation beacons. Now, what these propagation beacons is part of the International Beacon Project, is they put beacons in various parts of the world that transmit every so often on 2 meters right in this band right here. And if you can hear one of them, you know that the band is open very, very long distances to one of these other places, and you can try other stuff in there. Now, the next thing that shows up here is a satellite, and it says /Oscar. That's orbital satellite carrying amateur radio, so that's the same as satellite. But we do have satellites up there. Usually the uplink would be on like 440 and the downlink on 2 meters or something like that. There's all different kinds of combinations, which are called modes, which is different from SSB as a mode, etc. But you see you have place here for satellite uplinks and downlinks, and here is a place here for satellite uplinks and downlinks just below 146 megahertz. Now, if you look at the ARRL band plan, this Colorado thing that I showed you here dates back to 2005. Now, there is a newer, and it's 14 years newer, the ARRL band plan also has a new Oscar subband and something they call linear translator inputs and linear translator outputs. These are satellite, but they are not FM satellites. This is where you can put CW or single sideband up and get it back down over here. And the device on the satellite that does that is called a transponder. Okay. A transponder does that. So we'll just add that to our thoughts here in the satellite areas here. These transponder satellites are actually far more difficult to work and far more interesting than the kind that you can do with a handheld antenna. And some people really get into this. They're pretty fantastic. You have to work with Doppler shifts and moving antennas and things like that. And some people take that as quite a challenge. Now, there is an area in here. Oh, first of all, satellite Oscar, oddly enough, right in the middle of the satellite Oscar subband is the United States APRS frequency, right in the middle. So much for band plans, huh? Anyway, 144.39 is APRS in the United States, and that sits right here in the satellite Oscar band, but it is very widely used. Now, if you go down here to the weak signal, FM Simplex, digital and packet, you actually find your packet frequencies there. They're 145.01, 03, 05, and a few more like that. And these are the frequencies that you'll find packet on. Now, the interesting thing about packet to understand is that you can use a standard FM radio to do packet. And even a handheld if you want to, because what these packet modes do is create an audio stream that goes out over an FM radio, okay? And the only way packet will work is if you have a nice quiet channel, because packet is very hard to deal with for errors. So this brings up the second kind of radio that we can have here. Okay, FM radios. Now there are handhelds, and FM mobile radios. Now, usually in your home, if you have just FM, you're going to use a mobile radio in your home. And here I'm showing a picture of mine. It's a Yaesu up here that I use for FM, my base station. I also have some handhelds, which I've tested from home, but more often use those on the road. And also in my car, my truck, I have another mobile radio that can be used from the truck for mobile. Okay, so we've talked about FM, and now we get into FM repeaters here, okay? This are FM repeater inputs and FM repeater outputs, okay? And they're 600 kilohertz apart. So if you go in here, you'll be coming out here 600 kilohertz below. You go in here, you'll come down here 600 kilohertz. Again, always 600 on 2 meters. This was a mistake, by the way. When the first amateur repeaters were seeing the light of day in the mid-1970s, when I was a student at BYU, it was very exciting that they had put a repeater in the area. And these just basically followed commercial practice. Commercial practice for repeaters at the time had a 600 kilohertz spacing. Now the problem with that is you need to do some difficult filtering to keep the input from interfering with the output, okay? And they used big giant filters called cans to do that. When we started putting repeaters on 70 centimeters, we spread the repeaters out more, 5 megahertz, which means that it's much, much easier to separate the input from the output. Now, down here, this is where you can play with anything on 2 meters. There's miscellaneous and experimental modes. You can do meteor scatter. There are all different ways of doing that. You can, the various JT65 modes, there's a set of sub-modes that go with that that'll work in here. Meteor scatter actually works fairly well on 2 meters. You're not looking for the big giant meteors. Well, you are. I mean, you'd like to see one, because then that trail will support meteor scatter communications quite well. But even little tiny dust size meteors can create an ionized trail enough to reflect something from it. Okay, so that's the bottom half of the band. We've got some FM, we've got other modes in here. The packet that goes in here is actually an FM carrier for that. Now let's look at the top half of the band. And the top half of the band is all FM repeaters. Okay, we'll just come out just a little bit here. Okay, so starting at 146, we have FM repeater inputs and FM repeater outputs. Again, 600 to there, or it could be there to there, all right? Now, the also FM repeater inputs up at the top of the band you've got the same 600 thing, okay, it'd be 600, and so this upper half here goes with this, and this lower half goes here. Now I say upper, lower. These are higher in frequency as you go down. Sorry, that was a little confusing. Now you also see large chunks set aside for FM simplex. And by convention, these are just FM. These are not digital or anything like that. There's nothing in the 2 meter band plan, except maybe if you go into the miscellaneous and experimental modes, where you might play with, say, DMR or something like that, the digital repeaters in the American band plans are on 70 centimeters. Okay, but you're saying, wait a minute, like this little handheld I have here, it's the Radioddity GD77, this will do DMR on 2 meters or 70 centimeters. Well, the repeaters are on 70 centimeters. Now, what is going to happen over time is that some of these repeaters, they'll modify the band plan so that they can do some digital with this down here. Now, this still is quite general. So let's take a look at what we've done in Colorado. Now, every area has a document like this from the frequency coordinator, whoever it is in the area. Some areas back east will be multiple states. Okay, out here in Colorado, we just have one for Colorado, and other states have their own. But the frequency coordinator only coordinates FM repeater inputs and outputs. And here is the list of the pairs. Now that may seem like a lot. It's 79 pairs there. There's some emergency and special event, or down here, for example, there's some shared non-protected repeater pairs and so on. And these are repeater pairs. So every repeater in Colorado that's been coordinated, and hopefully that's all of them, will have one of these pairs. Allocated to them, it's theirs. Now, just to get into a little bit of some history, if you will, sometimes people will go to the trouble of getting a pair because they plan on putting a repeater up, but then they don't. And sometimes these will sit for a long time, years. And other people say, well, we want that frequency. Well, these people say, well, we're just a month away from getting our repeater up, you know. And it can create issues. I would say less than half these are actually in use. The ones that are, every one of these is allocated in the Denver area, every last one of them. In fact, the waiting period for a pair in Denver, if you ask for a repeater pair, the waiting period to get one is over 5 years. On 70 centimeters, it's about 5 years. So it's a little bit wild. Now, lots of repeater pairs. Here are the listed simplex frequencies. These frequencies are going to be different in different parts of the country. One frequency is always the same, 146.52. 146.52 megahertz is the national calling frequency. Okay, it's right here, voice simplex calling frequency. All of these others are available in theory for simplex. Now, one of the problems is that occasionally people will have crossband repeaters taking one of these simplex as an input coming out on 70 centimeters and vice versa. And they don't coordinate. And when they don't coordinate and you go try to use a simplex frequency, you get all tangled up with these other people. That has happened to me in Denver, okay, where somebody was doing a crossband repeater and I was trying to conduct a training net on an out-of-the-way simplex frequency. So anyway, they say they are simplex frequencies. If you're going to write one of these into, say, your organization's emergency plan, you might have 3 or 4 so that you'll have some backup if you go to one and find out that somebody else already picked it for that same emergency. There's going to have to be some flexibility. Now, in theory, nobody owns a frequency, but if you have coordinated a frequency and somebody else interferes with that, the onus is on the somebody else to fix the problem, okay? So that's kind of how the law works. You don't own the frequency, but it's been coordinated to you, therefore you have priority, and the FCC recognizes that. because there have been issues that have come up to do that. So what have we got for our 2 meter amateur band? We have got a lot of different kinds of activity on 2 meters. Lots of FM stuff is being done. FM voice, okay. Now, you don't get into things like amateur television or anything like that because you need to go up to the 70 centimeter band, which is actually 30 megahertz wide, as opposed to 2 meters, which is 4 megahertz wide. Our 220 band is 222 to 225 is 3 megahertz wide. But there's a lot of things that you can do on the 2 meter band. Now, if you're a new tech, you're probably going to be real interested in the repeaters. And some of these repeaters will be connected to the internet. There are all kinds of things that you can do. And you'll also want to get on your digital repeaters that are up in the 70 centimeter area. Most handhelds these days are dual band handhelds. Okay, so 2 meters is a very interesting band. It's one that I've been on. I've had equipment for it since I was a fairly new ham. I think I bought some equipment. I got a little TR-22C Drake piece of equipment which had crystal control and a little microphone that hung off of it and a little 19-inch whip, and it was cute. And I really wanted one and finally got one, but everybody else was going to handhelds at the time. So I hope this has been an interesting overview of 2 meters, what it is, how you can use it, and things you can do. You are not limited to FM. You can, if you have the right equipment, like a standard CW or single sideband digital that operates on that. There are some radios, like the ICOM 70, let's see, it's the 7100, okay, that operates HF and VHF up in these regions here. The Yaesu equivalent is the FT991A. Okay, will also operate up here. This allows you to operate the sideband and stuff like that. And there is one from Kenwood. If I remember correctly, it's the TS2000 SAT. Okay, so there are radios out there that will do this. And you can get them and do all your FM stuff. They'll also do digital. This one does C4FM. These two will do digital on D-Star. The Chinese radios do DMR. If you've got an old Motorola handheld, it's probably DMR. So there's lots of things that you can do on this. So there is your introduction to the 2 meter band. We've talked about the 2 meter band, and it's a very, very popular band. A lot goes on that band. Now, you get in the cities, especially back east, it's a very crowded band. A lot of repeaters, all the repeater pairs are used, same on 70 centimeters. Now let's talk a little bit about the controversy that's been surrounding the band. Somebody in Europe, now Europe is Region 1, ITU, International Telecommunications Union, Region 1. We're in Region 2. The 3 regions in the world have different frequency allocations. For example, in Europe, they have a 4 meter band that we don't have. Now, there have been some people making noise about taking the 144 to 146 megahertz band to part of our 2 meter band and giving it to aeronautical. And this is a thing that has just been proposed in Europe. not proposed in the United States, but proposed in Europe to alleviate some crowding with their aircraft bands. Whether it will go anywhere is anybody's guess, because 2 meters is just as popular in Europe as it is in the United States. Now, if you want to fight that and make sure that that bad idea doesn't land on America's shores, there is a good way and a multitude of bad ways to go about that. Signing online petitions will get you nowhere. Writing to your congressman will get you nowhere. What you need to do is be a member of the American Radio Relay League and then make a donation. It's hard cash. A donation to the Spectrum Defense Fund. It's not just 2 meters that's under perpetual assault. The cell telephone companies would like some of our amateur microwave frequencies. So there is an active spectrum defense organization inside the ARRL. That's the way to fight this nonsense that works. There aren't other ways that work. So join the ARRL, contribute to the Spectrum Defense Fund, and learn what they have to say, and they'll tell you the best ways to approach the FCC and so on. If that ever happened in the U.S., well, it has happened before. UPS, many years ago, decided that it wanted part of our 220 to 225 megahertz band. And they got it. They got 2 megahertz of it, 220 to 222 megahertz. Now, what a lot of hams did not realize, because of all the hype, that we're losing our band, we lost 2 of the 5 megahertz. That left 3. Those 3 have been sitting there ever since. You're finally starting to see a little bit of Chinese equipment that will operate on the 220 band, but not much. But it's there, 3 megahertz just sitting there for hams to use. So this is what happens when hype exceeds reality. So let's make sure that we get reality to exceed the hype. Until next time, this is Dave, KE0OG. This slide shows a series of ways that you can provide financial support to this channel. And everything I have to offer here is free for the viewing on YouTube, but it does take some money to run the channel. So until we next meet, chins up, join the ARRL 73.